Hello and welcome to this podcast from the BBC World Service. Please let us know what you think and tell other people about us on social media. Podcasts from the BBC World Service are supported by advertising.
My earliest memory of watching a spider weaving its web was when I was about 11 years old. It was in the back garden of our new house. Of course, I'd seen spiders' webs before, but they were all quite small, no bigger than the palm of my hand. But this one was about 2 feet wide, easily the biggest I'd ever laid eyes on. And what's even more impressive was the size of the insects entangled in the sticky strands. Big bugs, solid juicy flies trapped in threads so delicate you could hardly see them. I moved in closer and very gently touched the web with my finger. Immediately I jumped back with excitement as the spider scuttled across the silken threads to investigate. Spider silk is amazing stuff. Weight for weight, it's about 5 times as strong as steel, yet it's finer than human hair and can be stretched several times its length before it breaks. Astonishing. For all the marvels of human engineering, the big bridges, the clever buildings, the ships, the rockets and trains, I don't think anything comes close to a spider's web. There's so much we can learn from the animal kingdom. Hello, I'm Patrick Aye, and welcome to the very first episode of my brand new podcast, 30 Animals That Made Us Smarter, from the BBC World Service. It's a series about animals and also about us, humans all around the globe. More specifically, it's all about the remarkable things animals can do and how we might copy them to solve problems in our own world. You see, the natural world is full of problem solvers. After all, they've had millions of years to test things out, to learn and adapt from trial and error. So now it's our turn to take inspiration from them and to emulate their solutions in our own designs. Take that spider's web in my garden, for instance. Because spider silk boasts this rare combination of being both lightweight and extremely strong, it's been the subject of considerable research as scientists work on spider-inspired materials. Everything from bulletproof vests all the way through to parachutes. But they're not the only thing spiders have inspired, as you'll hear later on in this series. This process of designing materials and structures that are modelled on biological systems is called biomimicry, and we're surrounded by it. In our homes, our offices, our cars, right down to the technology we use in our day-to-day lives. I'm fascinated by this stuff, and it all began with that spider in my garden. It was a moment that fueled my love of science and wildlife, as well as a curiosity for finding out how things work, how nature solves problems. I studied cancer biology at university, learning about how cells operate on a molecular level and how they respond to infection and disease. Since then, I've replaced the genetics lab with wild savanna and the open seas. I've been lucky enough to have travelled the world to make breathtaking wildlife films. And I've had some pretty unforgettable encounters along the way. From getting stalked by Komodo dragons, sprayed in the face by a skunk, to freediving with sperm whales. But I'm still just as fascinated by the natural world and what we can learn from it as that 11-year-old Patrick sitting in the garden. So let's get to it. In this series of podcasts, you'll hear the very best stories from across the globe of animals that have made us smarter. I really hope you like what we've got in store for you. And where possible, please rate us, and why not leave a comment too? On social media, we're using the hashtag 30animals. Our first story comes from Japan. Number 1 is Kingfisher and Bullet Train. The story of how a bird helped reshape the daily commute of millions. Many birdwatchers I know will tell you it's a really special day when they see a kingfisher. The common kingfisher is roughly 17 centimetres in length, a bit shorter than a pencil. It makes its home in dense cover near slow-moving or still water, as it mostly eats fish. Eiji Nakatsu is someone who's very familiar with kingfishers. Nakatsu is a birdwatcher, and he's also an engineer. In fact, he's a very good engineer. So good that in 1989, he was appointed General Manager of the Technical Development Department of Japan Railway West. This meant he worked on the new 500 series Shinkansen, or as it's more commonly referred to, the bullet train. Now, if you haven't seen one before, believe me, bullet trains are exceptionally impressive things. Like a machine from the future, they carry millions of passengers on some of the world's busiest train lines and are among the fastest trains on Earth. But in 1990, Eiji Nakatsu's team was set the challenge to speed them up even further. They had to make traveling in Western Japan from Shinosaka to Hakata Station in Fukuoka take less than 2 hours and 20 minutes. To do that, the train would need to clock up speeds of over 300 kilometers an hour. This was easier said than done, because the bullet trains had a problem, a very big problem. When the trains went through tunnels, they made a very loud bang, one that disturbed wildlife, made passengers uncomfortable, and woke up people in nearby houses. Teams of engineers were working to find a solution. It seemed like it all came down to aerodynamics. When the train hit the air at the start of the tunnel, it acted rather like a plunger being pushed into a pump. A rapid buildup of air created a shockwave, which sped ahead of the train down the tunnel rather like a bullet down a gun barrel. When the shockwave got to the other end, it exited the tunnel, and that's when people heard the bang. And because the shockwave moved at the speed of sound, the bang was heard before the train itself emerged. Bullet trains are fast, but not that fast. This was a problem for two reasons. Firstly, the noise was breaking Japanese environmental regulations, which said the trains had to be quieter than 75 decibels. That's about the same volume as a vacuum cleaner. When you need a train to travel at over 300 kilometers an hour, that's really quiet. And second of all, the compressed air was slowing the trains down, a bit like wading through water. If they could solve these problems, they could make the trains both faster and quieter. They needed a train that could cut through air more efficiently, to stop it building up inside the tunnels, and that, my friends, is where the Kingfisher comes in. Our planet is home to about 100 different species of kingfisher. Save for the polar regions and some of the world's driest deserts, they're found all over the globe. Most species are found in Australia, Asia, and Africa. They're generally characterized by long, sharp, pointed bills and large heads, with short legs and stubby tails. Despite their name, not all kingfishers catch fish, but those that do are very efficient, having exceptional eyesight and a beak that's perfectly shaped for plunging into the water after fish. Long, narrow, and highly streamlined, the beak steadily increases in diameter from the tip to the head. This reduces the impact when the kingfisher hits the water, as it essentially slides into the water, which flows past the beak rather than being pushed in front of it. And that's exactly what the bullet train was failing to do as it moved from the open track into a tunnel. Whilst he was mulling over this problem, Eiji Nakatsu happened to attend a lecture by an aviation engineer at the Wild Bird Society in Osaka, and discovered that birds had helped aviation technologists to solve some of their design problems. It got him thinking, if the front of his train looked more like a kingfisher beak, it could improve its aerodynamics, allow air to flow around it rather than building up in front of it, and in the process, get rid of the boom. And it turns out, he was right. Nakatsu and his team studied the kingfisher more closely. They found that the cross-section of the upper and lower beak was more complicated than it first appeared. It resembled two triangles with rounded edges, which together formed a squashed diamond shape. Nakatsu described it as a circular lozenge surrounded by 4 circles, which I have to admit is kind of hard to visualize. The point is, they designed a train nose which resembled a kingfisher's beak. As you can imagine, it looked a bit odd, and it was also a lot longer, 15 meters compared with 6 meters on the previous model. They tried a number of other designs as well, but when they tested it in a model tunnel, the Kingfisher train was faster, quieter, more powerful, and had 30% less air resistance than its predecessor. Problem solved. Well, not quite. There was a second problem that required another piece of animal-inspired innovation. The train was connected to its electrical wires overhead by a series of struts called pantographs. When the air hit these pantographs, its flow was interrupted, and a swirling mass of air was created like a miniature whirlwind, a miniature noisy whirlwind. So the team tried reducing the number of pantographs and changing their shape by adding wind covers. But the covers were heavy, they vibrated, and the noise could be heard inside the carriages. So the trains were, yes, quieter on the outside, but noisier on the inside. Once again, Eiji Nakatsu found the solution in a bird. This time, an owl. One of the reasons owls seem so extraordinary, even a bit ghostly, is their capacity to fly in almost complete silence. They make very little wing noise, which allows them to swoop out of the darkness onto unsuspecting prey. Nakatsu became intrigued by the owl's silent flight and experimented to see if the comb-like serrations on some of their wing feathers, which kind of resembled the edge of a saw and helped make them so quiet, could be applied to the bullet train. The team replaced the pantograph's original design with something resembling a set of downward-turned wings with small tabs. These tabs acted like the serrations on the owl's feathers, and sure enough, they broke up the whirlwinds and reduced the noise. Finally, there was just the supporting frame for the pantograph to sort out. Because it wasn't streamlined in shape, it also proved noisy. Once again, Nakatsu found the answer in a bird. The Adelie penguin has a body shaped like a spindle, which means it can move almost effortlessly through the water. So the pantograph supporting shaft was reshaped to be more like a penguin's body to reduce the wind resistance and the noise. So there we go, not 1, not 2, but 3 design problems solved by 3 different birds. 3 animals that really did make us smarter. It's not surprising now that an engineer might also be a keen birdwatcher. And so on March the 22nd, 1997, the new 500 series Shinkansen electric train was released into commercial service. The challenge had been to get a passenger from Shinosaka to Hakata Station in Fukuoka in under 2 hours 20 minutes and at 75 decibels or less. The train came in at 2 hours and 17 minutes and less than 75 decibels. At the time, this was a new world record for the fastest train on Earth. And so the bullet trains journeyed on, leaving people and animals undisturbed, and the Japanese economy moving. But their noses are now a little less bullet-shaped, thanks to Eiji Nakatsu and his riverside bird. Now that I think about it, maybe we should call them Kingfisher trains instead. We have a fabulous animation to go along with this episode, which shows the Kingfisher morphing into a bullet train. Why not check it out? Head to our website, which is bbcworldservice.com/30animals. In number 2 of 30 Animals That Made Us Smarter, an original podcast from the BBC World Service, we'll be diving underwater to find out how octopus and squid are inspiring some very cool camouflage. Please do let me know what you think of this first episode. I hope you've enjoyed listening. It's been great fun making it. As we're brand new, we really are relying on recommendations, so please tell everyone you know about us and leave ratings and reviews. Don't forget the hashtag is 30animals on social media. Thanks for listening.